Good day, everyone. So, today we shall be looking at another topic in this physics subject, that is electrical resistance, electrical measurement. Electrical measurement, and the major measurement we shall be considering is resistance. All right. So, without much ado, let's dive in. Now, the first thing we need to consider is resistivity and conductivity. You see, every electrical material, especially wire, have what we call their resistivity and their conductivity. Okay. Now, resistivity of a wire simply is defined as the resistance of unit length of material of unit cross-sectional area. Okay. Now, it simply means the resistance of just one unit length of that electrical wire. That's what the definition of resistivity is. And its unit is ohm meter. The symbol is this omega symbol, ohm meter. Resistivity itself has a symbol of rho. All right. Now, resistance is the ability of a material, in this case now the wire, to oppose the flow of current through it. All right. The ability of a material to oppose the flow of current through it is called the resistance of that material. It's symbolized with capital letter R. And there is a mathematical relationship between resistance and resistivity, and that is resistance equal to the product of resistivity and the length of that wire over the area of the wire. This area is taken to be the area of a circle by r squared. Okay, so the area of the wire. Now, on the other hand, we also have another term that we talk about in electrical measurement, and that's conductivity. That's the symbol. Conductivity is just a measure of the extent to which a material will allow current to flow easily. Remember, resistance is the ability of a material to oppose the flow of current. But now, if the material allows some current to flow despite the opposition, now the extent to which that material will allow current to flow is now what we call conductivity, and it's always the inverse of resistivity. Of course, this one is resistance, while this one is allowing the flow of current. Resistivity is resisting current flow. Conductivity is allowing current flow. That's why they are what? Inversely proportional. So mathematically, resistivity is what? 1 over conductivity. Okay, resistivity is equal to 1 over conductivity, or conductivity is 1 over resistivity. That's the inversely proportional relationship. Now let's talk about some other terminologies in this electrical measurement. And the first one is the EMF, is an abbreviation that is known as electromotive force. Then we also have the internal resistance, and PD, which means potential difference, and finally the lost volt, or what we call lost voltage. Now these terminologies or these terms are important to know in electricity concept in physics. Now, what is electromotive force? Electromotive force, represented with capital letter E, of a cell is simply defined as the total work done in driving 1 coulomb of electricity around the circuit. So the work required to drive, the total work required to drive 1 coulomb of charge around the circuit is what we call the EMF of a cell, and the symbol is capital E. The next term is what we call the internal resistance of a cell. Okay, whatever has internal must have external. Now, the internal resistance of a cell, of course, we have said that resistance is the opposition to the flow of current. Now, internal resistance of a cell is the opposition to the flow of current offered by the cell when it is discharging current to a circuit. Now, when that cell is giving out current to the circuit, its own resistance is called the internal resistance of that cell. Then there's another one again, we call it terminal potential difference, which is written as capital V, or sometimes we use PD to represent it. It's simply defined as the potential difference between the terminal of a cell when it is delivering current to an external resistance. Now, the external resistance are the resistors like our bulb, our television, every other thing that is connected to that cell. Then finally, the lost volt or the lost voltage is the potential difference across the internal resistance of a cell. Now, each of these terms have their symbols. For EMF, we use capital E. For internal resistance, we use small letter R. For terminal voltage, we use capital letter V. For lost voltage, we use small letter V. Now, and then for the current itself, electrical, we use capital I. Now, mathematically, it has been verified in the laboratory that capital I, which is the current, equals electromotive force, which is the EMF, over the sum of external resistance and internal resistance. Again, another formula says that the EMF equals the terminal potential difference, which is the capital V, plus the lost voltage, which is the small v. All these mathematical terms are very, very key in solving problems in electricity. I will say that, shall we now talk about how to convert a galvanometer to an ammeter? A galvanometer is used for detecting and measuring very small current. But this galvanometer, there is it here, can also be converted to an ammeter. An ammeter is just an instrument for measuring bigger current. So galvanometer measures smaller current, ammeter measures bigger current. Now, how can you now convert galvanometer to ammeter? It's very simple. All you need to do is to connect a very, very low resistant wire to that galvanometer in a parallel form. You can see it here. This galvanometer here supplying receiving a current. There's a current flow. Now, if you want to convert it to ammeter, you just get a low resistance resistor called a shunt. It's called a shunt. Get a shunt and connect it in parallel, as it's going to be done now. Look at it now. A shunt wire. That's it. It's connected. That's it here. The low resistance shunt wire is connected to in parallel with it, and automatically this is now an ammeter. So simply say that to convert a galvanometer to an ammeter, you connect a low resistance wire in parallel to it, and automatically it becomes an ammeter. Alright, again we can still convert a galvanometer to a voltmeter. A voltmeter is an instrument for measuring potential difference. Now, how do you do that? You just get a multiplier, what we call high resistance wire, connect it in series to that galvanometer. It becomes a voltmeter. You can see this is the high resistance, it's called multiplier, a high resistance resistor, connect it in series with the galvanometer, and automatically the whole connection becomes a voltmeter. So that is how to convert a galvanometer to either ammeter or to voltmeter. Okay, I want to say that let's talk about how to measure resistance itself. The major instrument for measuring resistance is actually called ohmmeter, but we have another means of doing that. We can use voltmeter and ammeter to measure a resistance. We can use Wheatstone bridge also to measure resistance. We can use meter bridge to measure resistance, and we can use potentiometer to measure resistance. Okay, any of this can be used to measure resistance. You will still get your value. Out of these four I have said, let us consider two of them. And the first one is the Wheatstone bridge. The Wheatstone bridge consists of four resistors connected in this form, in bridge form. We have resistor 1, resistor 2, resistor 3, resistor 4, and then in between them we have a galvanometer connected to it. Now, when this is connected in this way and an external battery, for you to know, remember we are talking about how to use it to measure resistance of a resistor. Now, out of these 4 resistors, one of them will have an unknown resistance. So, in a nutshell, having set up the connection, it has been proven that R1 over R2 equals R3 over R4. So whichever one that is missing there, mathematically you can now determine the value of that resistance. Okay, you can determine the value of the resistance of the resistor using this formula. Okay, I haven't set up this in the laboratory. The second instrument for measuring resistance out of the 4 is called the potentiometer. The potentiometer is a device that we use to measure potential difference as well as resistance of a wire. So in this case, we are considering it as an instrument for measuring resistance of a wire. Now, how do you go about it? Now, look at this connection here. In this connection, this AB represents the wire, okay, that you want to determine the resistance. Now, at the end of the connection, there is what we call jockey. This J here represents the jockey. It's movable. As you are moving it, the increase in length also increases the resistance of the wire. At the end of the connection in the laboratory, it has been verified that E1 over E2 equals L1 over L2, where the E1 represents the EMF of the first cell and the E2 represents the EMF of the second cell. The L1 represents the initial length of the wire, and the L2 represents the final length of the wire. At the end of the day, one of these will be unknown while the rest will be known, and you determine the unknown value using this equation. All right, that is how you use the potentiometer. It consists of an 100 centimeter wire with a meter rule connected to it to get the measurement, and then you have 2 cells connected. All right, now there is an advantage that potentiometer have over voltmeter when it comes to using it as an instrument for measuring voltage. The first advantage is that a potentiometer does not draw current from the circuit, or unlike the voltmeter that do draw current from the circuit. Because when you draw current from the circuit, you will not be able to determine the exact value, the precise value. Number 2 advantage of potentiometer over voltmeter is that it has no zero scale error. Okay, because you don't have to be looking at any pointer moving from one division to the other. You just carry out your jockey from one place to the other and get your measurement. So it has no zero scale error. And then the last advantage it has over voltmeter is that it gives an accurate reading for the potentiometer than the voltmeter. Okay, so these are the advantages that the potentiometer have over voltmeter when it comes to using it as an instrument for measuring potential difference or voltage. All right, so thank you for listening. This is where I'm going to draw the curtain. Until I come your way again, have a good day.